Our next practical is to find out the largest or smallest number among the 10 numbers. So we have divided this practically into two parts. First one is we will find out the smallest number out of 10 numbers, and in part B we will find out smallest number among 10 numbers. So as usual we will start with TASM, as this one is the eighth experiment. I have already written there to save the time. I will directly open the program with edit experiment 8a part we will open .asm. So this is the our program to find out smallest number from array of 10 numbers. Okay. As usual, I had made the declaration dot model small, and I have initialized the data segment with dot data assembler directive. I have taken array and given name as ARR, which is each of array element size is byte. So I have used a which is declared with the help of assembler directive define byte. Now in that byte we have 10 numbers, that is 10 elements of an array, and out of that 10 element we have to find out smallest number. Okay, so after getting smallest number we have to store that number. That's why we will take one more variable whose name is small SAML, this SAML, and with whose size will be 1 byte only, because all the numbers are has size 1 byte. So we have taken assembler directive for a small variable as a byte, defined byte, and we don't know current value of small variable small. So we will put question mark there. I have initialized the code segment with code segment with dot code assembler directive, and two instruction move x comma add data move ds comma ax. So this is the initialization of code segment, and we will start the program now. As usual we have 10 numbers. We have to store uh, we will work with a AL register, and we will take each value in AL register and we will compare that value with each number, so that we will find out smallest number. Okay, so initially we don't know the value, that's why we will make AL register as a 00h. To see the result clearly I will make AH also 00h. So that's why I have made the I have I had written the instruction move x comma 00h 4 times 0h. This will, after execution of this instruction, content of AH and AL both will be 00h, and after that I will take effective address of this array into the SI register, source index register. Now for that I have instruction LEA SI comma ARR. So this will load the effective address of ARR into the SI register. Now every time we do not have to take that we do not have to load the uh, effective address of that ARR variable. Okay, so that's why for that purpose we have taken that starting effective address or that effective address into SI register, so that we can increment or decrement SI as per our convenience. Now, first, after loading the effective address of ARR, the cursor will come over here, and it has a value 80h. Now, first, what we will consider, that this first value is the small value as compared to the others, because still we haven't done any comparison. Okay, so first value we will treat as a smallest number, and we will move that number to the AL register. Also at the same time we will move that number to the variable small. Okay, now as we know that we have to check 10 numbers, so we should have a counter. We know that in CL register we will store the counter, and And whenever we want to use loop, that time we have to consider CX register. For that purpose, what I will do, I will write such an instruction that CH content will be 00H and CL content will be 0H. So for that purpose, I have written instruction move CX comma for 3 times 0 AH. So CL will be loaded with 0 AH. This 0H will be treated as a count. Means whenever we will do comparison between two numbers, the count is decremented. So now currently we haven't done any comparison, so count is 10 now. As soon as we start comparing, then this count will goes on decreasing. Now here, what I have done, I have written one short label. In that, I have repeated the process. So one label I have written that the label name is repeat one. Okay. After that, I have written increment SI. As we have first element we have taken already as a smallest element. Okay. Now this has to be compared with this, and who is the smallest one? So my cursor should go, or compiler should go there. For that purpose, I have incremented the value of SI, because at the current position when loading, SI is loaded with effective address of ARR, and it is at current position this ATH. Now we have incremented by 1, means it will come over here 90H. So that 90H I will take into the AL register. That 90H I will take into the AL register with the help of instruction move AL comma in square bracket SI. So at SI we have data 90H. 90H will be loaded into the AL register. So now we have two datas. One is in small variable, another is in AL register. Now we will compare both, and we will check which one is smallest one. Now I will write the instruction CMP small comma AL. So here content of small, that is 80H, and content of AL, that is 90H, will be compared. Comparison will be done with the help of two's complement subtraction. Now here the thing will go like this: ATH, ATH minus 90H. So this will work, and it will generate result, say minus 10H. As we know that the result generated is minus 10H, means that the content of AL is larger than ATH, content of small variable. It indicates that whatever content we are having in small variable, that is already small than the content of AL register. So we do not want that smallest number. Smallest number is, it is already in small variable. As the, so whatever second number we have taken, that is larger from the first number. So we will keep at it, as it is. We will keep as it is. So here after subtraction, the minus 10 means borrow will be generated. Borrow is nothing but carry. So if carry is generated, I have to make it is clear that if carry is generated, means second number or whatever contents coming in AL register is larger as compared to the contents of variable small. So we do not want that contents of AL, as that are larger, and it will set the carry flag. If the carry flag is set, after execution of this, the carry flag will be set. to 1. So uh, if it is 1, we have to understand that we got larger number. Actually, we want smaller one. So if we got larger number, we have to skip that number and we have to check for next number. So for that, if I have written instruction, jump if carry flag is set, go to no change. No change is one of the label and it will loop the repeat one. It will loop the repeat one. Now we carry flag is set means condition for this instruction is satisfied. It will directly jump to this no change label. It will directly jump to this no change label. It will not execute this instruction small a small comma al. This instruction will be executed when we have positive number and carry flag is resetted. If the carry flag is resetted, it indicates that we got the smaller number as compared to the content of or number which is present in small variable. Now here 90h is greater than small variable 80h. So carry flag is set. The condition is for jumping is satisfied. It will jump over here. It will jump over here. Now here we have used loop prefix, loop repeater. Sorry for the pause. Now this condition is satisfied. Jump if there is carry. Now here we have a carry generated after the subtraction. So this will this condition is satisfied. It will jump to the label no change. At label no change, I have written that it should go to the repeat one again. Means we want to check the next number. Next number is 30h. To go to the next number, before that, I have checked one number. Okay, so my count should be decremented by one. For that purpose, I have taken prefix loop. Loop repeat one. What is going to happen here? Here content of CX register will be decremented by 1. If the content of CX register got 0 or 0 flag is set, then this is which is the condition for exit. It will not go to the repeat one. It will execute next instruction. Now currently content of CX is 000AH. If it is decremented by 1, it will be 0 triple zero 9AH. It indicates that uh, we have checked one number. We have checked one number and 9 elements are remaining. Now it will go to the now condition is satisfied. It will go to the repeat one. Now at currently the cursor is at this location 90h. Now I want to go to 30h. For that purpose, I will increment the value of source index register because it will contain the effective address of ARR. It will uh, it will take the effective address of ARR as we have seen by execution of this instruction LEA SI comma ARR. Now after incrementation of SI, my compiler will come over here. It has value 30h. Now we will compare that 30h with our value 80h. Okay. Now for that purpose, this 30h which is present in the memory whose effective address present in SI register has to be moved to the AL register. For that purpose, I have written instruction move AL comma SI. So in square bracket SI. So SI contains the effective address of the memory location of the variable ARR. At that location, we have value 30H, and 30H will be moved to the AL register. Now that 30H we have to compare with the current small value. Current small value present in variable small. In small, we have value 80H. Now this 80H will be compared with 30H. So 80H minus 30H. So it will generate the positive result, say 50H. If the positive result is generated, it will not generate the carry flag. That is, carry flag will be reset. There is no need of carry or borrow. Okay. So what is going to happen here? If the carry is not generated, it indicates that we have got smaller number as compared to previous one. That is content which is already present in variable small. Now what we will do? We got the smaller number. We will put that small number into the variable small. Now after CMP small comma AL, the carry flag will be resetted to 0. It will be reset. If the carry flag is reset, this condition for no change will not be which is unsatisfied. Now JC, if no change, jump if there is no carry flag, jump if there is carry flag. Now here there is no carry flag. The condition is unsatisfied for this instruction. It will execute next instruction. In next instruction, we have written that move small comma AL. Content of AL currently it is 30H. 30H will be loaded into variable small. 30H will be loaded into variable small. And again we came to here. Loop repeat 1. So what is going to happen here? Here again the content of CX register, which is currently 00009H, will be decremented by 1, and it will be checked whether it got 0 or not. If the content of CX becomes 0, it will come out of the loop and it will come to execute this instruction. Now currently content of CX register after decrementation, it will be 0008H. Okay, 0008H. So it is a not 0. If it is not 0, it will go to repeat 1. Will go to repeat 1, and it will check. It will execute this instruction again. Now instead of loop repeat 1, we can use decrement CX register directly, decrement CX and JNZ repeat 1. These two instructions we can use sequentially instead of writing loop repeat 1. So meaning of or working of both uh, loop repeat 1 and DEC CX JNZ repeat 1 will be same. The same result we will get. Just the thing is that whenever we are executing this loop prefix, that time we will directly the scan happen in one stroke, means one step, single step we will get the result. And whenever we are using these two instruction, that time it will take time, means step by step it will execute. So this is difference between loop and normal instructions. Now as this we got smallest number 30H, again we cursor is at this position, we want to compare it with next number. So I have incremented SI by 1. So cursor will or compiler will come over here. It has value 05H. 05H will be taken into AL register again, and it will be compared with the current value which is present in small variable. In small variable currently we got 30H. 30H will be in 30H will be compared with 30H will be compared with 05H. By in comparison, we know that 2's complement subtraction will happen, and it will generate the result. It will be say 25H, which will be a positive result. and carry flag is not generated as we do not require carry for the subtraction. If the carry is not generated, it means that we got smaller number as compared to previous one. The same thing, what is going to happen here? Now we got smaller number. Here carry is not carry is reset, that is it is 0. If it is 0, we got smaller number and we have to store that number. So this instruction will not be this instruction condition for this instruction is not is unsatisfied. JC no change, jump if carry flag is set. Here the carry flag is actually reset, so condition is unsatisfied. It will not execute this instruction, it will come over here. Okay, it will execute the instruction that move small comma al. So current content of al is 05h will be copied into the variable small. Now we have checked one more element. We came here loop repeat one. After execution of loop repeat one, the content of cx register will be decremented by 1. So it will be 6 now. It will be 6 now, and it will be checked whether it got 0 or not, content whether cx is equal to 0. If cx is equal to 0, it will come out of the loop. It will come out of the loop and it will execute these instructions, shaded instructions. Now content of cx currently it is 06. Now 0006. So it will come over here and it will check. It will increment the SI content. The currently SI is at this location 05H. Now after INC SI, the compiler will move to the location here 95H. And this process will be repeated again and again until we reach last element 45H. As we reach 45H, comparison is done and we got smaller number. It will come over here and it will execute loop repeat one. Now after execution of this instruction, contents of cx register will be 0. As we reach to the end, count will be 0. Count will be 0. Count will be 0. As count is 0, we have to understood that we have reached up to the end for comparison operation and we have to stop here, and we got the smallest number which is present in the variable small, which is present in the variable small. Same variable is available, same value is available in variable al. So this is how we have to find we can find out how to find out the smallest number from array of 10 numbers. Okay, so now we will execute this program. New, save it, Tazo xpta, sorry, 8a actually, 8a dot asm. There is no error, there is no warning. Now we will link object files. T-link file name is expt8a.obj. There is no stack involved. Everything is okay. td. Now execute the program. expt8a.exe. Program is loaded. Now we'll execute. We will do the execution step by step. For step by step execution, we have key F8. So we'll execute it with the help of F8. Here, after execution of this instruction, move ax comma 4 times 0h. The content of ax will be 00h. 4 times 0h. Now first element occurred here 80h. F8. F8. The count is loaded. CL register is loaded with counter. 0h means 10 elements we are having. Second element we have taken 90H. Now after see loop repeat instruction. See here after loop we have address 0013H. Add 0013H we have instruction INCSI move AL comma SI compare what content of small register small variable with AL content. So whenever we are using a loop within single step, it will do all microprocessor will do all comparison and it directly it will give the result. See here we got the result smallest number as a 05H. If I press next, see here it will directly came to INT21H and terminated. So this is how uh, we have to use loop prefix efficiently. Okay, now we will exit from here. So this is how we have seen the program how to find out smallest number among array of 10 numbers. Now same thing, reverse thing we will use same procedure, but reverse thing we will use to check the largest number. For that purpose, I have written one program. To that program, I have given name exp experiment 8 part B dot asm. So this is the program where we have to find the largest number among array of 10 numbers. So same thing I have written here dot model small dot data, same data is there, same 10 elements we have taken. Instead of finding large number, small number in previous program, we have used here large variable. So instead of small, we have taken large as we want to find out largest number. Same size of byte. We have initialized the code segment. We have taken effective address of ARR into SI register. NAX will be loaded with 4 times 0H. First, as effective address is loaded into SI register, so it will come over here. It will ATH will be copied into the AL register and also it is copied into the large variable. So first element we will treat that it is a largest element. Okay. Now after that, after this, we will compare each element with the first element. Which one is largest one? Whichever is largest one, we will save that variable, that content in variables large. Now we know that count is should be loaded in CL register. So we have given instruction move CX comma 000AH. So 0A means 10 numbers we are having. For that counter purpose, we have 10. We have 10 numbers from 80H to 45H. So that counter should be loaded in CL register as CL works for counter. Okay. Now I have started the program. Next, I want to access the next element. So this ATH already taken in AL register as well as large variable. Now I have to go to this memory location and I have to access 90H data. So to go to the next memory location, I have written instruction INC SI, increment SI means after incrementation, it will come over here. After currently it was here, after INC SI, it will come over here. Cursor or compiler will come over here. Now that value I have to take into the that value is present at memory location, and from that memory location I have to compare that value with the variable value. Which one is largest one? I cannot do directly comparison. So that, instead of that, I will take that value in AL register. See here, move AL comma SI. Currently SI is as at is at 90H. So 90H will be loaded into SI, and that 90H will be compared with 80H. Now for that purpose, I have written instruction CMP large comma AL. So in variable large we have value 80H, and in variable AL we have value 90H. So it will be compared. Comparison can be done with the help of 2's complement method. So 2's complement method of subtraction. So 80H minus 90H will generate minus 10H. Whenever minus 10H the result is generated, it indicates it will generate the carry flag. It will generate the carry flag because whenever we are subtracting 80H from 80, 90H from 80H, that time it will generate borrow. It will generate borrow. Borrow is nothing but carry. So carry flag will be set to 1. Carry flag, if carry flag is set to 1, it indicates that we got the larger number than the previous one. Previous number is stored in the variable large. Now we got the largest number, and that largest number has to be stored into the variable large. So here, first of all, we will check the condition. If the carry flag is not set, JNC no change. If there is no carry flag, if there is no carry flag, we have to understood that whichever data present in AL register is small as compared to the content of variable large. Now here we carry is set. Carry is set means this condition will be unsatisfied. So if the condition is unsatisfied, it indicates that it is already indicated that content of AL is larger than content of large, variable large. So we have to store that larger number, which is 90H, into the variable large. For that purpose, I have written instruction move large comma AL. Now we have checked our numbers, and we will come over here to the no change loop. Okay. So what is going to happen here? I have used prefix repeat 1. As I have used prefix repeat 1, the loop prefix will decrement the counter or content of CX register by 1. So currently it is 000H, it will be decremented by 1. If it got 0, if CX becomes 0, the condition for exit is satisfied for loop prefix, and it will execute next instruction. Okay, it will exit from this loop. It will exit from this loop. But now after decrementation of CX register by 1, content will be reduced to 0009H. 0009H. So condition is unsatisfied for loop. It will come to the repeat 1. It will come to the repeat 1. Now at repeat 1, what I will do? I have done comparison of 80H and 90H. Now I have to do 80H with 30H. For to I have already at the position of 90H. I have to go to the 30H position. Now for that purpose, I have to go to the next location. That is, we have to increment the content of SI. After after the execution of instruction INC SI, it will be it will be 30. It will reach to the compiler or pointer will reach to the 30H. Okay. Now that 30H we will take into the AL register, and same will be compared with 90H, which is a maximum or largest number, which is the largest number, and that we will compare with 30H. For that purpose, 30H has to be taken into the register AL. So I have written instruction move AL comma SI square bracket square bracket SI. So square bracket of SI is nothing but effective address of what at the whichever effective address whatever will be the content, that is 30H, currently content is 30H, will be copied into the register, AL register. So AL becomes 30H here. Now it will be compared with the variable large. So in large variable we have 90H data. We have 90H data, and it will be compared with 30H. So whenever 90H minus 30H, after, means during the comparison, we will do the subtraction. It becomes 68. 60H. Okay. So here result is positive and carry is not generated. Carry is not generated. If the carry is not generated, it indicates that we got smaller number as compared to the previous one, and we do not want to store that smaller number. We want to skip this. If the carry is not set, the condition for this instruction is satisfied. Jump if no carry, jump to no change location. It will come over here. Condition, after condition is satisfied, it will come over here and loop repeat one. It will decrement the content of CX register, that is counter is decremented by 1, as we have checked we have checked two numbers, or we have compared two numbers. It will be decremented by 1 and it becomes 8. It will be compiler will check that whether CX got 0. If CX got 0, it will come over here. It will come over here and execute these three instructions. Now current content of CX after decrementing, it becomes 07H. So 07H, it is not condition for exit of the loop repeat one. So it will come over here and it will take next element. It will take next element 05H and will be compared with 90H again, which is stored in the variable large. Same thing is repeated until we reach here. When we reach here at 45H, the and 45H is compared with the whichever is the largest number. Now currently if you see here, larger number is 0A0H. At last I have written 0A0H. Okay. So so that 0A0H will be compared with 45H. Now we know that 0A0H is the largest number. Whenever this happens, comparison is done. The larger number is in variable. When comparison is done, in large we have 0A0, 0A0H, and in AL we have 45H. So if we do last comparison, it becomes 0A0H minus 45H. 45H. So some value will occur here. Some hexadecimal value will occur here, equal to. Okay. So whatever may be the value, the result will be positive and it will not generate the carry. If the carry is not generated, this instruction, if carry is not generated, means carry is not set, the condition for this instruction is satisfied. JNC, no change condition is satisfied. It will come over here and it will do loop repeat once. Now at this position, the content of CX register, as we went up to the last, it will be 1 only. And when it is decremented by 1, 1 minus 1, it will be 0. Content of CX register becomes 0. It indicates that we have reached the comparison up to the last element. And this is the when CX becomes 0, which is the condition for loop prefix, it will come out of the loop and it will execute next instruction. It will not go to the increment the content of SI, move the content of AL into, SI content into AL register. So this is not going to happen as our counter comes to 0, and it will execute this three instruction for program termination. So in this program, we have found the largest number, which is A0H. Now, why I return 0A0H? Because computer should not, compiler should not confuse that whether the 0A0H is the data or instruction. So if I write 0 in front of A0, it will be treated as a number, or we can say data. So we'll save that, save this, go to file menu, exit, type Taja file name is expt8b.asf td, sorry, t-link file name is expt8b.obj td8b.exe. Now we have came to the execution window. We'll do step by step execution. Observe here AX register. First, AX register is loaded with initial value 0. Then first element came into AL register, that is ATH here. After that, counter is loaded in the CL register with 0AH. Second number came 90H. Now directly loop instruction is executed. See here, cursor is at the loop instruction and I'm executing with the help of F8. As soon as I have executed the instruction F8 with loop instruction, I directly got the result A0H, which is the largest number, And counter, if you observe here, it is 00H. CL register contents are 00H. Means we reach up to the end of the program. Sorry, end of the data. That is 10 elements we have checked. Do F8. Okay, terminated. Go to file menu. Now this is how we have seen the program to find smallest and largest number of the among the 10 numbers, or we can say array of 10 elements. Thank you.